In this room alone, 10 women and 5 men will go on to experience a fragility fracture. These fractures happen when a bone breaks following an impact that you normally wouldn't expect would cause a fracture, such as falling from standing height. And these result in a reduced quality of life. So, reasonably, it makes sense that there's a great interest in identifying people at risk of fragility fractures sooner so that we can intervene earlier and give them treatment and hopefully prevent the fracture from ever even occurring in the first place. Currently, the gold standard is to use X-rays, which are bone density based, and they give information about if the person is likely to fracture or not, or so we say, because in 50% of women and 80% of men, this imaging technique actually tells people that they're safe from fracturing, but they still go on to have a fragility fracture. A better technique, in my opinion, is to use advanced medical imaging to detect and look at the internal structures of bone. And within this bone, you can actually start to visualize the structure, which looks more like honeycombs. And this honeycomb structure is what gives bone its strength, its resilience against fracturing. So then we can look at this internal structure and compare between two bones what their likelihood of fracturing is. So when we see one bone is more regular and has more well-connected honeycombs, we know that its risk of fracturing is less than a bone that has those honeycomb structures that are not as well connected and maybe they have some gaps. However, this still doesn't paint a complete picture. When we look at this internal structure of bone and pair it with clinical risk factors, which are the lifestyle factors that describe the person surrounding the bone, their age, their sex, weight, even their activity, we can get a better idea of if they're likely to fracture. And we can put those two inputs into our fracture prediction models. Still, we can do better. Let me give you an example. When you drop your phone and it shatters, do you look at the phone case, or do you think about the event that just happened that caused it to break? Chances are you start cursing yourself and thinking about what you just dropped it from, what the height was, what you were doing when that happened. My thesis is inspired by this. So rather than just focusing on bone alone, we start looking at the events leading up to the fracture, which is the fall. So for my thesis, I'm going to combine the internal structure of bone, those honeycomb structures, that fall risk that I just mentioned, as well as those clinical risk factors to better identify people at risk of fracturing. Because when we look at people in the real world, we don't just look at their bone. We consider the environment around them and what contributes to their risk of fracture so that we can hopefully intervene before they break a bone. Thank you.
Thank you, Raveen. Are there any questions? Oh.
Bryn.
How do you assess fall risk?
So we're going to be using muscle function and doing some tests within our wonderful CAB study that everyone should go sign up for and compare how people's hand grip strength compares to their just their muscle mass, which we have from DEXA, which tells us how much lean mass they have. And this has been done in other studies where they can get an idea. We're still playing around with using like a proxy for fall risk, but there's a few different studies, and it basically all relies on muscle functionality rather than just muscle mass, though. Yeah, thanks.
I have a question. Related to that, my Apple Watch gives me a prediction of whether I'm gonna fall. Have you done have you heard anything about that, or the legitimacy of that sort of research?
So that's interesting that you mentioned that, because I literally wear an Apple Watch. I threw it off before this, but I hadn't considered that. That is also an interesting source of data you can look at. I know that one study in our lab used balance boards, but I've heard that participants hated that because they don't like feeling shaky. But so there are some ways to track people's stability through day-to-day stuff, but it's, I don't know, the feasibility with the data set we have right now. It's right now we're looking primarily at the muscle functionality, but that's a good point you bring up, yeah.